We're going to talk about finding an inverse when there are some restrictions that we have to put in place that we can't forget about. And that comes from when you have a radical and you want to find its inverse. So we're going to start just ours by graphing the function. And because I'm not in Notability, I can't do my fancy graph the parent and then shift it over one to the right. So I'll make a table for those people who like a table. So again, you always start with what would it take to make this part equal 0, and that would be a 1. So that's the end point. That is where your graph begins. So we're going to do the square root of 1 minus 1, which is 0. Then we're going to try numbers that are going to give us good square roots. So I do want to use 2 because the square root of 2 minus 1 is 1. And that's really easy to use. So I'm going to go over 2 and up 1. Awesome. Then I don't want to use 3 because 3 minus 1 is 2. That's terrible. 4 minus 1 is 3. Gross. Let's use 5 because 5 minus 1 is 4. And we know that square root is 2. So I'm going to go over 5 and up 2. So basically your whole original graph has just shifted over. So instead of using 9, we're going to go up 1 more. We're going to shift over 1 because 10 minus 1 is 9. And that will get us this. So here is our graph. And I'm asking you what is the range because this is a super, super important question. We really need to take note of this. So the range of this is y is going to start at 0 and it's going to continue growing up slowly forever and ever. So you can either write y is greater than or equal to 0, or for those of you who like to do it this way, 0, and then it would go forever to infinity. So anyway, that's going to come back into play later. All right, so now it says find the inverse by using the points on the graph. Well, let's find our inverse. I'm going to use a different color. We'll use a little blue. So we're going to find the inverse. And we're just going to steal our points. So instead of 1, 0, we're going to use 0, 1. Instead of using 2, 1, we're going to use 1, 2. So you're just going to reverse everything there. Now, when you graph those, you're going to see that we have this blue and this pink that look like inverses. Because if you remember, the line y equals x is the mirror, it's the line of reflection. And these do look like mirror images of each other. So, the blue one looks like half of a parabola, in fact. Oh, and I made a little minor adjustment to my blue graph. You can see that the blue graph looks like half of a parabola. So now we're going to algebraically find this inverse, okay? So we're going to take our original function, we're going to take the f of x and make it into a y, and we're going to now switch x and y. So we're going to write x is equal to the square root of y minus 1, okay? And we're going to square both sides of this just like we normally do. So square it, and we're going to say x squared is now equal to y minus 1. Super easy. Let's just add 1 point. You might be thinking, why is this in like the A-level version? Well, this is why. This is not the actual answer, unfortunately, because if you went into Desmos and graphed x squared plus 1, you would find that it is a parabola. I'll give you a little quick sketch, where it has shifted up 1. And this looks like our part right here, but this part does not exist in our picture. And that's where the restrictions on the range become the same restrictions for the domain. This is the answer with a but. Y equals x squared plus 1, but only for x is greater than or equal to 0. Just like we switch the x and y, you're going to take the range and you're going to replace it with an x for the domain. So this becomes the final answer. The whole answer is this. X plus 1 equals y, where x is greater than or equal to 0, which matches our picture. It's only this half of the parabola. So that's something to remember. Just know when you're doing a square root, you're only going to have, since you have just a little hook, you're only going to have just half of a parabola when you're done. And if you can remember that, then that's the A level part of it.